Okay, guys, we are starting our next chapter, and it's actually a combination of chapters 3 and 4. For some reason, your book splits. Half of 3 is equations, half is calculations, and then 4, half is equation, half is calculation. So we're going to combine the beginnings of 3 and 4 and then the endings of 3 and 4. So we're going to be doing some calculations and then looking at chemical formulas and equations. So we're going to start today with the chemical formulas and equations. So the law of conservation of mass is quite possibly the most important law in all of chemistry. So what it says is that there is kind of a finite number of molecules, and whatever you start with, you have to end with. So you can't create more molecules, and you can't get rid of molecules. You can change how they are kind of in cooperation with each other, so you can make new compounds, you can pull them away from each other, but you can't actually change how many there are. So if you put 2 oxygen molecules into a reaction, you have to get 2 oxygen molecules out. So this is what leads us to equations, which we'll need to balance, and then that we're going to be able to do calculations with. So the first things we need to do is make sure that we have the same vocabulary together for a chemical equation. So when we start off section 3.1 of chemical equations, just so that we're on the same page, a chemical equation is a representation of a chemical reaction. So there's kind of 2 parts, what we start with and what we end with. So our equation is kind of split in half here. And on one side, we have the reactants. So we're split in half here, and on the left side, you have the reactants. The reactants are what we put into the equation. They're the things that are doing the reacting. So in this one, we have methane gas and oxygen gas that are coming together. The products are on the other side of the arrow. The arrow is called a yield sign. We yield or we make the products. The products appear on the right side of the reaction. So in this case, we've got carbon dioxide gas and water. The other thing that we need to add is the states of matter of the reactants and products, and they're written in parentheses to the right of each compound. So we can see that in this reaction, everything happened to be a gas. That won't always be true. We've got a couple of different options. So a gas is going to be that lowercase g. If we were to have a solid, it's going to be a lowercase s. A liquid is going to be a lowercase l. And then there's one more option. The last option is called aqueous. And that's an AQ in parentheses. Actually, most of what we work with in class is aqueous. Aqueous means that it has been dissolved in water. So oftentimes for lab, I will have a solid powder and I will dissolve it in water, and that makes it easier for us to work with. So when I have something dissolved in water, it's called aqueous. All acids are aqueous, and most ionic compounds as well. Okay, so we're going to put together our last chapter, ionic, covalent, and acidic compounds, with this chapter, which is our equation. So we're going to take a word equation. Maybe this is the procedure in a lab or information that you're reading about, and we're going to get together a balanced equation. So when we do this, we need to keep in mind of a couple things. First, for ionic compounds, we need to make sure we're using the crisscross method. So we're going to have to write the charges, crisscross them, and then write our final product. We're going to show our work today in all of our stuff. Next, we're going to add in symbols. So that's going to be our solid, liquid, gas, or aqueous. For now, we're going to put them where we can, but eventually we'll be able to put them in everything as we get further in the chapter. And then the last thing we want to watch for diatomic molecules. So remember, that's our have no fear of ice cold beverages. So anytime we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, or iodine by itself, it becomes diatomic. If you have it as part of a compound, you'll follow the same rules that we learned in our last chapter. So this is only for when it is just the element by itself. So let's try one of these. So sodium phosphate reacts with calcium nitrate to produce sodium nitrate and calcium phosphate. So the first thing we need to do is figure out what compounds are we dealing with, and then we're going to follow either our ionic or covalent rules. So sodium phosphate. Since it starts with sodium, sodium is an alkali metal. This tells me that this is ionic. So I am going to find my charges. Sodium is group 1, so it's 1 plus. And then phosphate, I'm going to look on my cation anion sheet, is PO4 3 minus. So to create sodium phosphate, I'm going to crisscross my charges, and I'm going to write my final answer down below. Again, you guys, you are showing your work on this, so I want to see those charges. The next thing I see is reacts with, and reacts with tells us that I'm going to combine something else with it. So in our formula, this is going to be a plus sign. You might also see the words combines with, added together, anything like that, that's going to be our plus sign. So we are adding it together with calcium nitrate. So again, calcium is a metal. It's an alkaline earth metal, group 2. So I know this is going to be ionic, so I need to use my charges. Ca2 plus, and then nitrate, I'm going to look up on my cation anion sheet, is 1 minus. I'm going to crisscross, and this becomes Ca, NO3, 2. Okay. To produce, so this is what I'm making. I'm going to my products. This is going to be my yield sign, my arrow. I might see to form, to make, to produce. Those are all going to tell me, okay, now I'm ready to go to my products, what I'm ended with. Okay, next I've got sodium nitrate. Again, sodium is a metal, so I know this is going to be ionic, so I need to use my charges. Na1 plus, and nitrate is NO3, 1 minus. They're both the same, so they are going to cancel, and I get Na, NO3. And is going to be a plus sign. And then I've got calcium phosphate. Calcium, we already said, is a alkaline earth metal, so this is going to be ionic again. So Ca2 plus, phosphate is PO4 3 minus. When I crisscross, I end up with Ca3, PO4 2. And in this particular one, we weren't given any of the state symbols, so we're not going to add in solids, liquids, or gases. And then also, we're not going to balance right now. We'll do that a little bit later. So right now, we're just getting our words into formulas. Let's try one more together. So we've got potassium iodide reacts with bromine, forming potassium bromide plus iodine. Okay, so potassium iodide is our first compound. Potassium is an alkali metal, so I know it's going to be ionic. I need my ions, my charges. And the iodide, the ide ending tells me it's just iodine, which is a 1 minus. So when I crisscross, that's Ki. Reacts with, okay, I'm adding something else to it, so that's my plus. Bromine, it's just bromine, so I know it's not a compound. So if it's a single element like bromine, I need to go to my diatomics list, and bromine is my beverage at the end of that saying. So I know that it needs to be diatomic. So I'm going to write Br with a subscript of 2. That 2 is in there because it's a diatomic. Forming. Okay, we are making, so that's going to be our arrow. Potassium bromide. We already said at the beginning, potassium is a metal, so it's going to be K1 plus. And then bromide, that ide ending tells me it's bromine with a charge. It's going to be KBr. Plus iodine. Okay, so again, it's not a compound, it's just iodine. So I'm going to go to my list of diatomics, and iodine is on there. So it's going to be I2. If it wasn't on the list, you would just write I, and then you'd be done. That a lot of metals are not diatomic, and so if you were to have like sodium metal, it would just be Na, sodium. Okay, I want you guys to try the next one on your own and then check answers. Okay, so hopefully you got the same answer. Sodium oxide is ionic, so Na2O, combines with, as my addition, water, H2O. To form is my yield sign, and then sodium hydroxide is also an ionic, so Na plus 1, OH minus. So you guys, at this point, you're ready to try the homework. It is the word equation practice sheet. You can stop in my room and grab it, or I will post it on my Moodle page and you can print it out or just do it on a sheet of lined paper.